Hello everyone. We want to take a look now at analyzing some data and using Excel to find a line of best fit or perhaps a curve of best fit. So let's say, for example, I'm trying to prove that global warming is a real thing, and the data that I use is my average gas bill over a period of 6 years. And so what you see here is the year in the first column and then the average monthly bill in the second column. And you can see that it started off in 2016 at about $100 a month and then dropped down into the 70s over the last couple of years. And so I might argue, hey, look, I'm paying less for heating my house. And so that must be because it's getting warmer outside on the average. I'm not saying that that's the case or not, but let's just say that that's my argument. So what I want to do is I want to analyze this data and see whether or not that's substantial. We want to look at a line that will fit this data. Okay, so the first thing I want to do is I really don't want to use the year 2016 because that's a big number. So let's change the year just to 1 through 6. And one way I can do that, you may already know this, is I'll highlight these first two, 1 and 2, and then I grab this lower right-hand corner until I get the little plus sign there, and I just drag that down until it becomes a 6, right? And so there's years 1, 2, 3, 4, 5, and 6. And then I'm just going to take this information right here, and I'm going to copy it. So I go to Home, Copy, and of course I could use a Control C to copy that, and then I'll paste those values. Okay, so what I want to do now is graph that just to see if I see any kind of a trend in the data. So I highlight both columns, and I want the x-axis to be the left-hand column or the first column I highlight, and the y-axis is the second. If they were not adjacent to each other, I could still do that. For example, I could highlight this first column and then hold the Control key down and highlight the second column, and that would still graph the data for me. But I've got them right next to each other, so let's just go ahead and do that. And then I need to go to Graphing, and that's under Insert. And then I want just points, so I want a scatter chart here. And I just want the points. I don't want any lines or curves to go in between them. I just want the data points. All right, and so here is our information. Let's go to this chart title, and let's just label that gas bill. All right, so you can see that there's kind of a downward trend in this data. All right, so you can kind of see that that goes down like that. That's not a very good line of best fit, but you get the idea of what that's going to look like. So what I want to do is I want to click on the data points. Doesn't matter which one because it'll highlight all of them. And then I want to right click on there, and you'll see some choices, and the choice I want is Add Trend Line. So I click on Add Trend Line, and you can see the choices are over here. We're going to stick with linear because I just want a line. I do want to display the equation on the chart. And you can see the line here, the little dotted line here that goes through, and there's about as much above as there is below. Talked about that in a previous video. So I'm going to display the equation on the chart, and I want to display the r-squared value. Remember I talked about the r-squared value in a previous video as well. And let's get that out of the way so I can see that. And there's the equation of the line. Indeed, I've got a negative slope, so my bill on average is going down. But you'll see the r-squared value is 0.6, which is really not all that great, right? I would like an r-squared value to be as close to 1 as possible. I'll point out in other sciences, depends on the precision of the measurements and how well the items you're measuring will obey the rules that are being looked at. That number should be really pretty high, like 0.9 or above, 0.8 or above maybe. In the social sciences, when I did work in education, a value of r-squared value of 0.6 was actually pretty exciting because it told me a lot, because human behavior's got such a scatter to it. But we're doing engineering here, or geology, I guess, if we're talking about global warming. So an r-squared value of 0.6 isn't really all that great. Well, maybe part of the issue is that the line or the curvature isn't linear. Maybe it's exponential. So let's try an exponential function. You can see the function there. Still, trend line is about 0.6, so that's really not much better. It doesn't really look much different than the line, does it? All right, so that's just a small portion of this exponential function. Logarithmic function, well, I've got my r squared value up to 0.7, so that's a little bit better. I'm going to skip down here to power function, 0.7 again. So again, better than the line, but not necessarily all that great. And then we go to a polynomial, and you can see that this is a second order polynomial. You'll see our order here is of 2, so I have an x squared. R squared is improved to 0.7. I would like to point out if I increase my order, there's 0.3, a little bit better, 0.4, much better. And then a fifth order polynomial, and you can see my r squared value is 1. And a lot of that has to do with the fact that I have 6 data points. And so a fifth order polynomial, x to the 5 power, will almost always fit that perfectly. And we'll talk more about what a reasonable function is in a later video. But the idea here is I got a perfect fit. So it doesn't look like it's global warming. It looks like it's global oscillating according to this. And we know from geology that taking a 5-year, 6-year sample is really not a very good sample, right? So let's go back to linear. All right, so there's my linear function. R squared value is not all that great, but you get an idea of what's going on as far as the scatter of the points above and below that line. All right, so that just gives you an idea of how to use Excel to fit the data. And in this particular case, I tried to fit it to a linear function, not very successfully. So it's not really very linear data. But we'll look at other data that fits the functions nicely. All right, I hope that helps a little bit with figuring that out. If you have any questions on fitting data to curves or to lines, as the case might be, we also did curves, of course, exponential, polynomial, logarithmic. If you have any questions on that, please do leave them in the comments below. Thank you.